In this video, we're going to take a look at the Unity Profiler, which I have found to be one of the most useful panes within Unity. So let's take a look here. Here we are in the AsteraX game as it was at the end of the previous challenge. Now in Unity, I'm going to go under Window and open up the Profiler window. Now there is a lot going on in the Profiler. You can scroll down over here and see several different things going on. To start with, I'm just going to hit play and we'll take a look at what we see in the Profiler window. So I hit play and you can see that it starts updating the Profiler window. There's lots going on here. Let's just have a few events happen. So I click start. Okay, that was there. Big jump there. And then I shoot an asteroid. We get another big jump. Shoot another asteroid, get another big jump. Let's pause. So this is what you are looking for whenever you're using the Profiler. You're looking for big spikes. Remember, this is the one we saw when we first started the game. Then we see this one here when we shot an asteroid, and then another one when we shot an asteroid again. So what we're trying to do is discover what's causing these big spikes, because when there's a big spike there, our frame rate goes down. You can see we go from well over 60 frames per second to less than 15 frames per second in this frame that takes a very long time. Now this is the one where we just started the game, so that's not as bad. But some of these other ones right in the middle of the game can be a problem. On our PC, PCs are fast, my Mac is fast, that's not a problem. But when you're dealing with a mobile game, that can be a serious issue. So what I wanted to do in this video was sort of dig down into this and show you some of the ways that we can look at this and see what might be causing these big spikes. So first of all, over here under CPU usage, you can see there are several different categories. And the color sort of denotes what's going on. So you can see that the biggest part of my problem has something to do with physics. And if I want to, I can actually turn off all of these other ones to just view physics. Now, it is rarely the case that your scripts are going to be the biggest spikes that you see. So this is also really useful. I can just turn the scripts on and you can see where the scripts have spikes in performance or decreases in performance. But let's go back to this physics thing and take a look. So you can see that the physics jumped up to 175.39 here, and then it jumped up to 38.17 milliseconds here, and about the same here, 35, 37, right? So what's going on? So in the beginning, we have two spikes, and you can see that there's this run delayed dynamic frame rate, and then if we click the right arrow, you can see there's pre-update, physics update, and there's something going on here that's taking up half of our processor in that frame. Physics interpolation, collider transform, rigid body transform, mesh, bake scaled mesh, physics collision data. So this is nothing, right? It's got 0% here. But this is 53.7% bake scaled mesh. Okay. And you can see that its sub-process here is not very much. So this is the actual process that's taking time. Mesh.bake scaled mesh physics collision data. Okay, that's good to note. Okay, so we've seen that it's this baking of the physics meshes that is causing the issue, and it happens every time we shoot an asteroid. So if you search online, you'll find that this has to do with baking meshes for mesh colliders as opposed to other more primitive colliders. And if you'll recall, if we go here, you can see that these asteroids, all of my asteroids, have mesh colliders, and they have children which have mesh colliders. So when we were working on this, we determined that it was probably that whenever we destroyed an asteroid, it had to sort of rebake the collection of mesh colliders together for the new smaller asteroid that had child asteroids on it, and that was causing the big jump in the physics. So when working on this project, we determined that probably what was happening was that because there were so many mesh colliders on these asteroids, it was sort of baking those into a single mesh collider for the complex object with the asteroid and its sub-asteroids. And then whenever we destroyed the main asteroid and upgraded the smaller asteroids to sort of primary asteroids, it then had to rebake those collision meshes, and that's what was taking the time. So as a result, we determined that if we were going to make a mobile version of the game, we needed to switch to more simple colliders for the asteroids rather than using the mesh colliders that seem to work just fine on my Mac. Now for this test, I'm going to turn off physics and turn on just scripts here. And what this will do is we'll make sure that vertically it's zoomed to my scripts rather than zoomed to the physics, which we know gets really, really huge. I'm also going to clear my data before I start. And then I'm going to hit play, and I'm going to go through roughly the same experience that I did before. So I'm going to click start, and then shoot again. Okay, so now you can see that I do still get some spikes in my scripts. Now you'll see here that right now it just has 0 milliseconds here in terms of what's taken up, which is not true because it's taking up more than that. But that's because I have editor overhead selected down here. If I hit shift and click editor overhead, that deselects that and allows me to see the spikes for everything. This allows me to focus on individual methods and see if those methods are what's causing the issue. So let's go back and see, okay, here's our first big spike, and this is post late update script run delayed dynamic frame rate. Again, we can dive into this and see what's going on. Coroutines delayed calls, then asteroids start and instantiate and awake, and you can see that again we've gotten down to this mesh.bake physX collision data. So when the asteroids are created and start is called and then awake is called as part of the start when it's instantiating sub-asteroids, part of what happens with that is baking that physX collision data, and that's what's taking up all the time here. You can see that individually this thing by itself is taking up 30% of, like 31.2% of the 32.1% that's happening here. So that we know about. That's an issue that we've already solved. That's great. Let's look at some other spikes. Here's a spike. And again, if I click on something and then shift click it, that'll deselect it. So it's taking 2.24 milliseconds. And script run behavior update, okay. Behavior update, level advanced panel update. And so we can see that part of this game object activation and deactivation is taking some time. It's taking a significant amount of time to do that. And again, we can keep diving into this. Now, I probably mentioned before, editor overhead is just something that happens. It's big and it is only going to happen within the editor. So anything that's editor overhead, you don't need to worry about when you're trying to debug for a delivery platform. Now, if you click in any of these other rows of the profiler, you switch what happens down below. So here, if I click in the rendering row, you can see that now I'm looking at draw calls and total batches and the number of triangles. And you can see that it's very low. And then I start the game. And now that I've got 3 asteroids, I'm looking at, 36,000 triangles, 100,000 vertices. So there's a lot more going on. And as I destroy asteroids, you can see that that goes down and then back up as some things go off screen and come back on screen as we loop around. Similarly, you can see what's going on with memory, and it's really important to understand what's going on with garbage collection. So I'm going to turn off everything else here, and you can see these sort of spikes in garbage collection. This is when we're allocating new garbage memory that needs to be collected. In C#, we don't handle memory allocation and deallocation manually like you would in something like C++. So we're generating kind of garbage all the time, and that garbage needs to be collected. Usually this is not a big deal, but sometimes on a mobile platform, you will have a garbage collection cause a frame rate hitch. And then, of course, there are several other rows that you can look at. I highly recommend taking a look at the documentation for this. There's so much interesting stuff going on in here, and it can really help you to better understand what's going on with your scripts. The last thing that I wanted to point out was deep profiling. So deep profiling, if I click on it here, you see it requires me to reload the scripts, and then I should really go ahead and just stop and restart again. But when I deep profile, it allows me to get deeper into the calls themselves and see more of what's going on in my scripts. And that just helps me to find in more detail what's causing me issues in my game. So again, you can see here, I'll turn off the garbage collector, I'll turn off others, and I have a pretty significant spike here in asteroid start again. Here it's in behavior update, level advance panel update. And so all of these things can really help you to better understand what's going on with your script. All right, so that's it for taking a look at the profiler. I just wanted to give you a kind of an overview and sort of show you how I might approach trying to track down a problem in a game I was working on. I definitely encourage you to look into it more yourself, and I hope that you enjoyed this video, and I'll see you in the next one. Thanks.